Hello, everyone. Welcome to Building Instant Loading Offline First Progressive Web Apps. A huge title. It turns out if you put all the buzzwords in it, then people come and see it. It's great. What I want to talk about first, though, is spam phone calls, which I actually get a lot of. You know the sort. It's like, have you been in an accident in the last 100 years? Would you like car insurance for all of your pets? That kind of thing. I actually get enough of these kind of calls that I've started inventing games to play when it happens. And my favorite game is And in this game, I become the most indecisive person who has ever lived. It goes like this. Hello, Mr. Archibald. Are you interested in saving money on your mobile phone bill? And I reply, I suppose if... and at this point, the caller usually tries to hurry things along, but it's very important that you don't let them. Or they'll say, like, well, we've got a great deal. And you go, wait. Do you mean, is it one of the, and you get a point for every second that they aren't talking. And it's a really difficult game because the person on the other end of the phone gets frustrated pretty quickly because you're directly blocking in a conversation, which is a very synchronous transaction where we're used to getting an immediate response. And you're kind of breaking that deal. We expect a similar model when it comes to getting data from a computer. But that wasn't always the case. Like 25 years ago, our expectations were quite different. Like if you wanted to know the directions to somewhere, you had to go to the room with the computer in the room and turn it on, and you would get all the fans would start whirring. You get this sort of static crackle as the CRT monitor whirred into action, and Windows 3.1 would slowly boot up. And then eventually, you would get your desktop, and it would do this. Because this was an era where booting up successfully was a fanfare-worthy moment. But even then, you had to find and insert the CD, which had all the maps on it, whatever, and print that off, and then off you went. These days, we don't need to boot up Windows. We don't need to boot up the one computer we have, because we have a computer in our pocket, which is already booted up, and we can ask it for directions. But often, that data comes from the internet. And if we have zero connectivity, and we ask the web for something, the answer is often no. And I remember when I first realized how problematic this is. A few years ago, I was working at an agency, actually just around the corner from here, and I found myself needing to go to the toilet following a lunch that my stomach was unhappy about. It was slightly off meat at Borough Market, I think. There were 5 cubicles to choose from at the agency. But in this one instance, the first 4 were occupied. Not usually a problem. I tend to only need 1 cubicle. I felt even in this situation, 1 cubicle would have probably been fine. But from previous experience, I knew that mobile connectivity and office Wi-Fi only extended to those first 4 cubicles. And I thought for a moment and decided, no, this is not acceptable. And I returned to my desk and I waited until later, despite being in some physical discomfort. And this is the day I discovered that I required an internet connection just to take a shit. It was an eye-opening moment. So this is definitely a problem worth solving. And until recently, there was nothing you could really do about it, especially during the initial page load. But all of that changes with the ServiceWorker. I was told that this slide wasn't impactful enough by my boss. I don't know what impactful means. It's one of those management terms. But I did give it another go. Came up with this. He tells me this one has brand issues, which I don't really understand. It's got loads of brands in it. Should be fine. Bruce Lawson, the deputy CTO of Opera, he had a go. He came up with this, which I love. It's great because if you stare at it, it feels like the colors are changing. The colors are changing. There's a filter animation going on. But Ben Jaffe at Udacity kind of outdid himself, and he came up with this.
For too long, users have been left staring at a white screen. For too long, they've been let down by the cruel seas of network connectivity. And for too long, we've been powerless to help. We've been left waiting. But no longer. A new browser feature has arrived. A total game changer. feature that lets you control the network rather than letting the network control you. Who is this new feature? And what promises does it bring? Introducing the ServiceWorker.
It's a bit much, isn't it? I prefer mine. It's got Sonic in it. It's fine. But what does this all mean? What can the ServiceWorker actually do? Well, we're going to take a look at a Mojoy, which is a little progressive web app, which you can find at this URL. It's like a simple version of like Google Hangouts or whatever, but it only lets you enter emoji. It started life as a mere website, but over time it was built to be a fully progressive web app, and it didn't require a full rewrite to do this. It's something that happened incrementally, bit by bit. And this here is V1 of it. It runs at 60 frames a second. It's kind of cool. It's really simple. Doesn't use any framework, so it's only like 25K all in, so it loads really, really fast. Unless, of course, you're offline. Well, actually, it does load fast. It's just the user experience is not so great, right? We want to fix this. This is how it was when I first launched it, and here's how I fixed it. So to begin with, registered for a ServiceWorker. And this isn't some kind of magic manifest format or a config file. It's just JavaScript. And this is an important decision we made. We didn't want to invent some new thing when we have a world full of JavaScript developers out there and existing tooling and stuff. Oh, of course, we should wrap this register call here in a feature detect because, well, there are other browsers out there, older browsers that don't support ServiceWorker, and a simple feature detect prevents them from hurting themselves and others around them. Anyway, in this script, I'm just going to put a simple log. Now, if I load the page and have a look in DevTools, you can see that log there. Great, cool. Also, we can see this new application tab, which is in Canaries, is heading its way to stable. And you see there's a ServiceWorker section there, and it's like, OK, this is registered. Brilliant. It says it was last modified in 1970, which puts us well ahead of the curve, having a ServiceWorker back at, predating the internet. That's pretty cool. That's a bug. I think we fixed that already. But how has this changed things? What has this done, adding this ServiceWorker? How has it impacted our site? To find out, we must go to the Comparinator. Fight! First up, the online experience. Go. OK, so it's around about the same. Is there a bottle of water at the back? Could I get a bottle of water? I'm feeling hungover. So I recorded these with a throttled internet connection, or as most of the world calls it, their internet connection. So, and I also closed the browser before recording this, so like it was loading fresh from the start. What about the offline experience? OK, so no difference there, just sort of flat-out failure. And you probably noticed not much has changed. Well, one thing happened. It logged hello, and that's all it did. Because that's all we told it to do. And that's how ServiceWorker works. It only does what you tell it. And that's a good thing, because I'm really sick of these sort of magic APIs like AppCache. With AppCache, if you add a manifest to a Mojoy, and all it contains is cache manifest, which is just required to make it a valid manifest, that turns the render of a Mojoy from this to this. And I can't help feeling that I didn't tell it to do that. AppCache was a bit of a disaster. It's this really sort of simple format, but it completely changes the rules. And if you don't like any of those rules, then tough. You're restricted by the way the designers of AppCache wanted you to work. And those designers hadn't created many offline websites before. This gave rise to the Extensible Web Manifesto, which most browser vendors are now fully behind. In this manifesto, we acknowledge that browser developers and standards developers are not better at web development, at building websites, than web developers. And we should stop tossing out these little scraps from our ivory towers, like AppCache, like the CSS to do reflection in one particular way, like things that we just saw. I mean, WebKit just added this spring CSS animation thing. For me, that's not extensible web. It's this sort of odd high-level thing that doesn't really do anything. We want to give developers full control, like give you as much information as we can, as many hooks as we can. Providing you with these kind of low-level bits and pieces, you can create things that we didn't consider. You can use patterns that we didn't invent. And these become like sort of evidence for higher level features. We look at what you're doing, we think, oh, right, everyone's doing this, so we can add a high level feature that sort of makes that faster or simpler. So the stuff I talk about today is going to be the patterns that I use, but you'll find your own patterns. So ServiceWorker is driven by events, and one of these is fetch. So we've got a listener for that here with a debugger statement. And if I run that, I'm going to take this update on reload, and I'll show you why in a bit. And now if I refresh the page, I'm going to hit that breakpoint. And we can see there's an event object here, and on it there's a request object. And this is representing the request for the page itself. You can see the headers and all of that sort of data and stuff. But you also get one of these for every request that the page makes. So things like the CSS, the JavaScript. We get events for these avatars, even though they're on another origin, they're on Gravatar. Now, by default, requests go from the page to the network, and there's nothing you can do about it. But with ServiceWorker, it sits in the middle, and requests go via it. It controls them. But like other events like submit, like click, you can prevent the default and do your own thing. And this is where things start to get interesting. So instead of triggering the debugger, what I'm going to do here is I'm going to call event.respondWith, and this is saying, hey, I'm actually going to do something with this. I'm going to respond with a response, just says hello. So let's give that a spin. So now if I refresh the page, it says hello. Cool. So instead of going to the network, the ServiceWorker just handled that. So this actually works offline. That demo, it's rubbish, but it does work offline, so we're getting somewhere. And I don't have to respond to every URL, every request the same either. So I could have a look at the request URL, parse it. If it ends in .jpeg, respond with a completely different fetch. So event.respondWith takes a response object or a promise that resolves with a response. And fetch, that's what fetch gives us, a promise that resolves with a response. So these compose together really, really well. So if we refresh the page now, it's back, but all the avatars are cats. It's redirected them. So instead of doing something special based on the request, we can do things based on the response as well. So here I'm going to do the regular fetch, just passing event.request into fetch. It will do what the browser would normally do anyway. But we can have a look at the response. And if it's like a 404, we can fetch something else, otherwise respond with the response that we actually got from the network. So now if we do that, like all of our avatars are back. But if I go to some nonsense URL, we can see the 404 message. So ServiceWorker lets you intercept requests and provide like a different response. And you can do that based on the request, you can do it based on the response, or the response of a completely different request. You can compose it all together, you can do what you want. But this is just sort of playing around. You probably wouldn't handle 404s in your ServiceWorker. Maybe you would to do 404s offline, but let's do something more relevant to this particular app, to a Mojoy. A good way to dip your foot into the ServiceWorker pool is to create your own offline fallback page, something to show if the page fails to load. Because the current state of things is pretty bad on the web. Like the user comes to you for like the second time, or clicks the icon on the home screen. They want your content. It's your moment to shine. But without a connection, we crap ourselves to the extent that Mama Browser has to step in and defend us. And it does so by blaming the user. Like Chrome can't display this page because your computer isn't connected to the internet. And I think this is something that we're going to look to change. It's something that I know Opera are keen on. Instead of saying, this is your fault, the user's fault, it will say, this website does not work offline. And I think that's a really good step forward, because if we're competing with native, this is like an operating system level error message. This is like a blue screen. This is like, this has crashed, or this is not working. I think we can do better than this. So I create like a custom error page. It's still an error, fair enough, but at least we're owning the error ourselves. We're keeping the user within the sort of brand of the app. And it's something we can build on later on as well. I want to show this when there's no connection, but to do that, I need to save it somewhere. And so I'll need to store it up front, because this needs to work offline, right? It's the offline error page. So ServiceWorker has an event for doing these sort of things up front. It's the install event. And you pass a promise to wait until, and that tells the ServiceWorker how long your install is taking. And if the promise rejects, it tells it the install failed. The install event is fired the very first time the browser runs the ServiceWorker. And it's your opportunity to go to the network and go and get everything that you need to make this thing work offline. But now we need somewhere to store all of those requests and responses. There's a new API for this, and it's the Cache API. So the Cache API, it specializes in request response storage, but unlike the regular browser cache, stuff isn't removed at the browser's whim. So we put all of the stuff in there, and once that's done, the ServiceWorker can start controlling pages. So let's do that. So here I'm going to open a cache. I'm going to call it whatever I want. I'm going to call it static v1 for now. And then I'm going to add the offline page and the CSS that it requires. Now, if the cache fails to open, or it runs out of space or something, or one of these fetches returns a 404 or a 500, then the promise is going to reject, and that's going to go all the way up, and the browser will know this install failed, and it won't use this ServiceWorker. So once we're controlling pages, we know these things are in the cache. Notice I'm kind of giving all of these resources sort of like random, hashes in the URL. This means I can give them good caching headers, like sort of cache them for a year or whatever. Because even with a ServiceWorker, it's still good to have good caching headers, because that means if we only change one of these URLs later, the other one can come straight from the HTTP cache. You can work around bad caching with a ServiceWorker, but it's much better to work with good caching. But now we need to use this cache because it's not used automatically. So over in our fetch event that we saw before, I'm going to respond with a match in the cache, one that matches this request. Now, matching is done very, very similar to HTTP matching. So it matches on URL, method, vary headers, but it ignores things like max age, all of the freshness stuff. It doesn't pay attention to that. So with this code, if we request the offline page directly or the CSS directly, it's going to come straight from the cache. If there's no match found, it will resolve with undefined, so we need to do something about that. So if response is falsy, we're instead going to go to the network and fetch it from the network. Now, if fetch failed because you're offline or whatever, that promise is going to reject, so we need to catch that. And if the original request mode was in navigation, we can return the offline page from the cache. Now, we only want to do this for navigations, because if your JavaScripts fail to load, we don't want to return an HTML page in response, because it doesn't make sense. But that's it. Now, with that little bit of code, we give the page a refresh. It doesn't look like anything's changed. But over in the application hub, we can see the cache storage. There's our stuff. There's the offline page, and there's the CSS. But if we simulate offline now, which is just using this checkbox here in the application pane, there's also, you can do all that in the network panel. We refresh, and we get the offline message. Done. We can ship this. And that's what the Guardian did as well. Over on the developer blog, if you don't have a connection, like disable Wi-Fi or whatever, and refresh the page, they give you a custom error message, which is really nice. And there's a little Easter egg as well. You can complete a crossword while you're waiting for connectivity to come back. I'm not good at crosswords, but it's a really nice little Easter egg. Actually, when I recorded this, I didn't even look at the clue. Californian city, 3 letters, 9 letters. Probably should have got that one, really. Spend enough time easily cacheable. So we replaced this. We ditched it and just went with a manifest.json file. And it was a good opportunity for us to, you can have it, it's cacheable, and it was a good place to standardize all of that meta crap. So it looks like this, pretty simple. So once you have one of these and a ServiceWorker, Chrome will ask the user if they want to add it to their home screen. If Chrome detects that they've visited this site a few times, they seem keen on it. So this icon here, this comes from the icon set here. You can specify multiple icons. I tend to just go for one larger icon, so 512 by 512, and let the browser do the scaling for when it needs it. If your icon is a really large file, then you might want to provide smaller versions, which will be like a lower file size. But in this case, even the big icon is 5K, so I don't care. The name here, this comes from the name field. You see how this works. And then if the user taps on add to home screen, they get an icon on their home screen. So we've already seen where the icon comes from. This is the short name. If your short name and name are the same, you don't actually need to specify the short name, just name is enough. Later, when the user launches the app, Chrome will generate a splash screen, and it does that until the page actually renders. And this icon comes from the icon list. Chrome will pick a larger icon in this case. So in some cases, like just going for one larger icon, you can actually save bandwidth by doing this, because Chrome only needs to download one rather than multiple of them. The name here is the name. Background color you can set. And this sort of purple bar at the top there, it gets that from the theme color. So once the page renders, splash screen goes away. And the page that loads is the one that's listed in the start URL. And you'll notice that there's no URL bar there, and that's because it's display standalone. This all adds together to sort of make the whole experience feel like a native app. And that's why it becomes so important that we, at the very least, sort of own our own connection errors. And we don't want the default browser error breaking this native feel. This is something we can ship as well. This is an incremental improvement. When developing these sort of offline capable sites, it's a common error to start iterating on this model, on this offline page. For example, make it show cached messages, make it a fuller offline experience. But doing that is an online-first approach, which works fine when the user is truly offline. But zero connectivity is not the worst thing that we face. This is. I call it LifeI. This is when your phone says it has connectivity, but it doesn't really. If you have LifeI and you ask for content, the web's answer, just that forever. This is worse than offline. Like with offline, you get a quick answer. It's no, but at least you get a quick answer. Here, you're just left waiting. And I'm pretty sure most of us in the room have experienced this, like at a train station when everyone's trying to, check train times because there's been delays or cancellations or something, and you end up just staring at the screen. You don't want to give up because I don't know. I get this sort of weird idea that if I cancel it, then if I'd waited like half a second longer, that's when it would have appeared. So I ended up just staring at it for longer and thinking, yeah, it's going to arrive in the next second. But does it? No, it doesn't. And you're forcing the user to stare at this or give up. And with every passing second, they hate the user experience a little bit more. So our current online first pattern, it works really well when the user has a good connection. They get the latest messages reasonably fast. It works pretty good offline. They get some cache data or a failure page in this case. But with LifeI, that's it. That's all they get. Now, Chrome removes the splash screen when the site gets to first render, and with LifeI, that never happens. We've improved things for offline users, but LifeI users are in the same hell that they were before. This is the problem with offline first. We're giving users with some connectivity a worse experience than users with no connectivity. And it isn't just down to poor connectivity on the user's device. Sometimes you can have this sort of full signal and still be experiencing LifeI. And this is because a lot happens just to get data from the web. Like your phone has to send a signal to the Wi-Fi router or the cell tower, then onto the ISP through intermediate proxies, potentially across to the other side of the world, through more proxies and stuff, and eventually lands at the destination server. But that's only half the journey, because that request has to come all the way back across the world through ISPs, proxies, et cetera, and land safely, hopefully, on the user's device. But if something along the way runs slowly, then the whole thing runs slow. And this is where LifeI happens. And you don't know what the network connection is like until you try. And trying takes time. There are actually a couple of APIs that sort of attempt to predict the network, things like navigator.online, navigator.connection.type. But these are really, really weak signals. They only know about that bit. They don't know any of this stuff. So, for instance, when navigator.online is false, you have no connection. That is certain. But when navigator.online is true, you have no connection. And that's the best we know. This will be true if you are connected to a cell tower or a router, although that router may only be plugged into some soil. Yet navigator.online will still be true. Anything after the first hop just cannot be predicted, not synchronously anyway. You have to make a connection and see, and that takes time. If the user wanted to come to our chat app and look at past messages, why should they need a connection for that? Why should users have to wait for a connection to see stuff that's already on their phone? The great thing about local data is you don't need to make an internet connection to go and get it. This is why the gold standard is offline first. Offline first solves these problems. With offline first, we get stuff from the cache first, then try and get stuff from the network. And the more you get to render without going to the network, the more offline first it is. You should see that the network is a piece of progressive enhancement, an enhancement that might not be there. So we need to rethink our approach a bit here. We're going to create an application shell. An application shell is just the page without the messages in this case. And then we're going to leave it to the JavaScript to go and get all of the messages from the network. So to do this, we're going to change the install event so it caches the shell, the CSS, and the JavaScript. Cool. And meanwhile, over in our fetch event, we're going to start by getting the URL so we can parse it. And if the origin is the same as the ServiceWorker's origin and the path is just /, we're going to respond with the shell, because that's a request for the root page. Done. Otherwise, we're going to try and respond with cached content and then fall back to the network if there's nothing in the cache. So altogether, with this, we fetch the HTML, the CSS, and the JavaScript from the cache. That gets us our first render without the network. Then the page's JavaScript goes and fetches the chat messages, and that gives us our content render. And if that fails, the JavaScript can show some kind of error message. So what do we win by doing this? We must return to the comparinator. Fight! I love that because everyone gets really sick of it really quickly, but I kind of like it. Anyway, how are we doing? Online experience. We've massively improved performance by getting to the first render without the network, even though messages are still coming from the same network connection. The reason it's faster is because all of this stuff came from the cache. It was able to start the request for the messages much sooner than the plain old online-only version. What about the offline experience? OK, cool. The shell loads, the JavaScript puts the error message up. Fine. What about the LifI experience? Well, it's not great, but it's better. At least we've defeated that sort of blank screen. Our JavaScript could show a spinner here or something, but things are looking loads better. You can see the sort of benefit of the offline-first approach here. Like, we wrote some code, and rather than improving things for just one connection type, it's improved across the board. We're back in control of the user experience. And it's taken us very little code to get there. This is something we can ship. But what about caching chat messages, so we can display those before going to the network as well? So the messages are, aside from the initial page load, they arrive one by one over a WebSocket. And this continual feed of data doesn't really map so well to the cache API, which is based on request and response. Instead, we want a store that we can add and remove individual messages from and iterate over them. And the web has such an API. It is called IndexedDB. IndexedDB has a bit of a bad reputation among developers, I think it's fair to say. But it's only because it's the worst API ever designed in the history of computer science. Other than that, it's not too bad. But actually, seriously, 60% of the awful comes from this weird event system it uses. It should have used promises, but it predates promises. There is an effort underway to see if we can put promises in there without breaking compatibility. But in the meantime, I much prefer teaching sort of low-level web platform stuff than libraries and frameworks. But I'm going to make an exception here and sort of promote my own library. This is IDB. It mirrors the IndexedDB API, but it adds promises in where IDB should have used promises. Other than that, you're just using IDB. It's you read the same docs for IDB. The code's a lot simpler. It's like 1.2K. Yeah, there are bigger, higher-level APIs like Dexy, like Couch. There's lots of stuff. But if you're just wanting to be sort of bare bones but remove 60% of the awful, this will do the trick. So let's build a database for the messages that come through. Messages look like this: a little bit of JSON, ID, a user hash, date, and then the actual text content. If we were going to build a database for this using the IDB library, it would look like this. Start by opening a database, giving it a name, like a Mojoy in this case. 1 is the version number of this database. And then we have a callback to define the schema. So first, we need to create somewhere to actually store the messages. So we create an object store called messages, and ID is the key, because that's the unique ID that's coming down in the JSON. If you've done stuff with relational databases call them tables. IDB calls them object stores, but it's roughly the same thing. So we're going to read messages back quite often in date order. So we create an index on that. We call it by date, and it's indexed on the date property. So that's it. It's not too painful. And we can take this and we can start adding messages. So once we've got, this function happens whenever a message arrives. So we'll add it to the page visually. But we want to add it to the database as well. So we get our promise. And then we're going to create a transaction, a read-write transaction on the messages store. We get the store, .add, and pass in the message. And that's it. I don't expect you to remember all of this code. I'm just trying to show you that IndexedDB can be a little bit less scary with promises. If we wanted to get those messages, create a transaction on messages, get the object store messages, get the index by date, and then get them all, and it's done. That gives you them all. Now, of course, we can't just keep adding messages into the database. We need to perform some cleanup at some point. So say we wanted to delete everything except the newest 30 messages. So create a transaction, read write, get the index that's ordered by date. But this time we're going to open a cursor. This lets us sort of deal with messages one by one. The prev there means we're going to go in reverse, starting with the newest message. So I'll start by advancing 30. So that's the skipping over the newest 30 messages. And then I'm going to loop over the rest, calling delete on each one. OK, this example isn't as pretty as the other ones. Like I said, the library only adds promises in. You're still exposed to the rest of IDB's ugliness. But this is a ton cleaner than it would be with just straightforward IDB. So having a database full of messages means that we can fetch our app shell, JavaScript, and CSS from the cache. That gives us our render, and we can render with messages from the database as well. So we're getting content on screen without going to the network. And then we can go to the network for newer messages and avatars and things. If this network request fails, it doesn't really matter because we're displaying content already. That's a great offline experience. If the network is slow, then we're still showing messages. That might be OK. If the user's just going to check a previous message, we're winning there. But to see the benefits of this, we must once again gaze upon the comparinator. Fight! It starts to get irritating, doesn't it? It's great. The online experience. We check out the performance difference here. Like, we're on screen with content like really, really quickly. The offline experience, we get content rather than a complete failure. OK, the avatars have failed. We'll deal with that in a second. This is way better than the sorry message that we had before. And how about LifeI? We've gone from the most frustrating experience in the world to content. This is something we can ship. The only missing bit at this point, in terms of the full offline first experience, is the avatars. That's relatively easy to fix. So in our current fetch code, we're going to do something special for the avatars. So let's rewind a bit. So if the origin is to gravatar, which is where the avatars are coming from, we're going to defer to another function, handle avatar request. Otherwise, we'll just keep doing what we were doing before. So what does handle avatar request actually do? Well, we could try and fetch it from the network, and if that fails, provide some kind of fallback. That's fine. It's not a bad solution. We could ship that. But we could do something even better. We could get when the page requests an avatar, we could try and get it from the cache. And if we get a response, we'll send it back to the page, and then we're rendering without using the network. But we should go to the network too, because maybe we didn't have something in the cache, but also we want to update what's in the cache, because people change their avatars all the time. Showing an old avatar is fine, but we should have the new one there for next time. So off to the network we go, and if we get a response back, we'll put it in the cache. And that's it done. Oh, unless the page didn't have the avatar to begin with, unless we couldn't get one from the cache, so now we'll just send on the one from the network. Done. Now, HTTP calls this pattern stale while revalidate. And it's actually sort of in Chrome now as an experiment. It's in Canary, behind the flag. But we can emulate this with ServiceWorker and have it working for our users today. And the code for this is actually kind of simpler than describing it, I think, anyway. So in our handle avatar request, we'll do a network fetch, because we always need to do a network fetch. Either it is just to update the cache, or we need to send it back to the page as well. And we're going to use wait until to do some work in addition to providing a response. In the additional work here, we're going to get the network response, and we're going to clone it. Now, the way sort of network streaming works is you can only read a response once, and only one thing can read a response. And this is how the browser is really efficient when it comes to video. So if you're downloading a 3 GB video, you don't want to have to end up with that whole 3 GB in memory. It wants to be able to consume bits and then get rid of it. Here, we want to use the response twice, because we want to send one to the page, maybe, but we definitely want to send one to the cache. So we clone it at this point, so we've got 2 hanging around. And the browser's smart about buffering the data that hasn't been read twice yet. I'm going to open a cache, avatars. This one doesn't have a version number, because I want these to exist beyond versions, like they're not going to change with the ServiceWorker. And then put the avatar in the cache. Done. Meanwhile, we're going to return a response from the cache. And if that returns undefined, because there's nothing in the cache, we'll defer to the network fetch. And that's it. It's a fairly small bit of code. Now, sooner or later, you'll need to sort of go into that avatars cache and sort of clean up, because you don't want to just keep adding avatars and never remove them. But this helps a lot. So to see the sort of full solution here, for the last time, I promise, we must approach the comparinator. Fight! I love that more than anyone does. That's great. The online experience looks like this. Instant, full content. The offline experience, instant, full content. LifeI, this is the important one. Instant, full content. In fact, the experience is exactly the same no matter what the connection type is. The network only matters when it is getting darker, right? I'm not having a stroke. OK, that's good. No, it's fine. I kind of like it. I've kind of felt like I was being I've worked. What's the word? Oh, OK. What's the word when you're being sort of interviewed but in a nasty way? Interrogated. Thank you. That That word just disappeared from my internal dictionary. So the network only matters. The network only matters for getting that new content, which isn't always essential. This is something we can ship. So we've achieved network resilience, right? That's pretty good. But there is one bit missing. It's great when it comes to showing data to the user, sending data to the user, but less so when it comes to the user trying to send data to us. I really hate this, and all websites do this, because I feel like as a user that my part in this transaction is complete. Like I've said, here are some smiley faces. Please send them to people. You don't need anything more from me. But no, in this case, you're requiring the user to kind of watch it through to completion, to stare at the screen while it happens. We can do better than this. So background sync landed in Chrome a few months ago now. It's a ServiceWorker event that you request. You're asking to do some work when the user has a connection, which hopefully is now, but could be later on when they gain connectivity. So say we had a function that was called whenever the user tries to send a message. We'd add that message to an outbox. This is a function we'd write. So we just add it to IDB or something. And we get the ServiceWorker registration and call .sync.register on it and give it some kind of name of our choosing. Now, this can fail because if the user's disabled kind of background syncing and stuff, so you should catch that. And if it fails, you just try and send the message as you normally would using just XHR or fetch or something like that. But if it did register, over in the ServiceWorker, we're going to get this sync event when the user has connectivity. We can have a look at event.tag, see what kind of sync we're supposed to be doing, and then we're going to use event.waitUntil so the browser knows how long the sync is taking, get the messages from the outbox, and then send them to the server, delete them from the outbox, done. And the effect of this is the user can be on LifeI or totally offline, but they can use the app as if they were online. So here I'm sort of going into airplane mode. But I can still use the app. It will still load because of all of the offline first stuff we did before. But I'm going to write a message. I'm just going to enter in like some cats. And I can hit send. Now we just add it straight to the output, like as if it is already sent. It does say sending there, but we don't put a lot of emphasis on that because now the user can just sort of get on with their day. They can even close the browser. You can lock the phone. They can put it in their pocket and just carry on about their life. And then later, when they regain connectivity, the message will be sent in the background via that sync event. There it goes. So the user doesn't even know this happened because they don't need to. Their part in the transaction was complete. They hit send, but it will send in the background, and users can reply. The only time they sort of find out that it's happened is when they start getting push messages. Oh, people have replied to the message you sent while you were offline. We had some questions actually when we were sort of building this feature. Every feature we add, that we always get the question of like, what's the impact on battery life for this? And there was a little bit of worry because it was background stuff, which was sort of fairly new. So we had questions around the battery life there. And someone pointed out, I was like, no, this is actually good for battery life because a little bit of background work uses a lot less battery than the user having to stare at the screen, with the screen on and the network trying to connect. So as well as being a really nice user feature, it will actually save the user battery on their phone. All it improves the user experience. And if you do this sort of stuff, I think it's totally cool to sort of brag about it. This is something that the IO website did. Like it would pop up and say, hey, this is, future visits are going to work offline. And I think this is great, but I do hope this goes out of fashion. Like it reminds me of those little badges like on the site where it says, this was built with CSS 2.1. And if you see them on the web now, you're like, oh, you use CSS? Well done, you. And I hope this will seem as ridiculous one day. But before that, we need to kind of build up user trust. Who recognizes this? This is what I'm greeted with on the bathroom on the train I commute in from Hayward Heath to London Victoria. You walk in and you're faced with sort of all the instructions and buttons. You have to press D to close the door because the instructions are there, and you have to press L when it's flashing to lock it. It's really nice because there's Braille there as well, so even blind people know they have to wait for the flashing light, which is great. And the buttons are horizontal. I don't trust this. I don't trust this because once it failed on me and slowly revealed me to the carriage like a bad game show prize. Similarly, users don't trust the web to work offline, and that's something we have to deal with because it's failed them before. So messages like this actually help. And yes, all of my epiphanies about user experience do happen in bathrooms. But this is why Chrome requires things like a ServiceWorker, like a manifest, before it will start telling the user, hey, you can add this to your home screen. And we're going to tighten the rules there as well to sort of hope to detect like a good offline experience. Because we want everything that is on the home screen to be as good as a native app. We don't want these browser error messages firing up. We want to make the web a first-class part of the operating system in the user's mind. And that's what we did with Mojoy. And achieving this wasn't a matter of rebuilding the entire app. It was a kind of incremental thing, improving the experience every step of the way for everyone. Like, things got faster for users who had good connectivity. Things stopped being frustrating for users with LifeI. And things become possible for users that are offline. People keep asking me about Android instant apps, because that's apparently a thing now, and what that means for the web. Well, progressive web apps are possible today. And that's the important thing. Like one app across thousands of devices, operating systems, and browsers. ServiceWorker in particular, it's now in Chrome, Firefox, and Opera, Samsung browser as well. It's coming to Edge. It's a high priority implementation for them. It's under consideration by Apple. And Apple are always difficult to read. But they send all the face-to-face meetings we've had. They've always had someone there. And at the next one, they're sending 3 people. So that's exciting. And 2 of them are quite high-up engineers. And it's either good or it's really bad, right? And I'm just like, would they send 3 people to Toronto to tell us to fuck off? I don't know. So we'll find out next month. It's exciting. But progressive enhancement means you can use it today. Like nothing's stopping you using it today. And if you use it and your sites become quicker in Chrome, and Firefox, and Samsung, and eventually IE, if they become faster in those browsers than Safari, then that gives Apple more reason to implement this stuff, because they're not in the business of making a slow browser. As web developers, you're in the position of power here. You get to guide the future of the extensible web. So ServiceWorker lets us build great user experiences, from becoming like faster, network resilient, to implementing like polyfilling network features like the stale while revalidate thing we saw earlier. And I know I've gone through a lot of stuff at lightning speed here, but there is a free Udacity course, which is fully interactive, where you take a site from online only to sort of full offline first. It covers everything that I've talked about today, but in more detail. Don't worry about remembering the URL. Just search for like Udacity offline something. Yeah. And with that, thank you very much.